On the last video, we talked about revolving a solid about certain axes, and we could calculate the volume by adding up disks. This one we're going to talk about finding volume, but this time we're going to add up shells, sort of like adding up like tin cans without a top or a bottom, or Coke cans without a top and a bottom. Little thin cylindrical shells. So once again, you might want to write down this website. So you can go there again and kind of look at some of these other surfaces, but I like it so that you can get an image of what we're doing. So let's just look at this first one. There's the region, and this computer is slicing it up into different partitions, and it's going to take one of those little partitions right there and then revolve it. It's revolving about the y-axis. And notice it's making kind of a shape of a tin can. It's making a cylindrical shell. Remember that the area of a cylindrical shell is 2 pi RH, 2 pi the radius times height. All right, so now this is adding up all of the shells. So it's taking each different interval, and it's actually doing a half shell, just so it can show you kind of how each one of those half shells is now added up. So now there's the smallest shell, next shell, next shell. It's adding all of those shells. And when we do this adding, we're integrating, and we're making these shells really, really small, really, really thin. And now it's going to actually revolve the whole object so you can see what it looks like. It looks kind of like maybe a block of wood with a bowl cut out of the middle of it. Okay, so there's the image of what we're going to be doing, and let's look at some examples. So actually the first thing that I want to do is kind of give some guidelines as to how I do this. So first of all, remember that the area of a cylinder and the area, let's actually call it a cylindrical shell. The cylindrical shell is 2 pi radius times height. So if you have some sort of a shell kind of like this, it would be 2 times the radius times its height. So there's the area. So we're going to be adding these up. So first thing, draw a picture. The second thing, draw a shell. Draw one representative shell. Now, these shells, you're going to draw them where they're rotated, or where the middle of the shell is going around the axis of rotation. So draw the shell, and then you want to figure out what integral you are adding with respect to. So d what are you integrating with respect to? What integrate with respect to, and then you want to find r and h, and those both need to be in terms of your variable, in terms of the variable from 3. So in terms of the variable that you're going to integrate with respect to. Now a little bit of guidelines here. So for r is either going to be x or y, or it could possibly be like x plus or minus some number, or it might be y plus or minus some number. H, for the height, you're always going to use your function. So use your function or functions. Okay, so keep that in mind. The radius always has x or y just to a first power. Could have plus or minus a number in there, and then for h, you're going to use the functions. Okay, I'm going to use the same exact shape as we did in the last video. So that one, and again, I'm just going to set up all these integrals. So let's set up the integral. find the volume of the solid, solid with region bounded by, we used the function y equals square root of x. We used x equals 0 and x equals 4 and y equals 0. And if that region that's bounded by that is revolved about, let's first do the x-axis. That's what we first did the last time. Now the last time we used disks. We drew a representative disk. We used pi r squared. This time we're going to use these shells. All right, so I'm going to draw my picture. I've got y equals root x. I've got x equals 0. That's just the y-axis. I've got x equals 4. I've got y equals 0. And we are revolving about the x-axis. Okay, so the shell has to be where its center is going to be around that x-axis. So its radius is going to go from that x-axis. And so if we draw in the middle of this shape, if I draw a line through there, and then I revolve that line around it, I get a representative shell. Now this can be part of half the battle here, is actually drawing an appropriate shell. Some tricks: the radius is always perpendicular to the axis of rotation, and this is for shells only. The radius is oh, that's not true. It is true for washers as well. The radius is perpendicular to the axis of rotation. So our radius is perpendicular to it, and the height goes through the shape. Okay, so now if I was to add up all of these shells, and I know you have to think back to the picture that I just showed you. The first one, the really small one, would be right around the axis. And then those shells would be getting bigger and bigger and bigger, and we are going to be adding up those shells then over y. They get bigger and bigger and bigger along the y-axis. So we are going to be adding with respect to y on this one. Okay, so if I've got dy, I now need my radius and I need my height in terms of y. Now the radius, that's right there. And if we go from the positive x-axis up, that is just a distance y. The radius is going to be y. Now the height is dependent on the function. We've got the height right here. And that height starts at 4 and then subtracts the function from this guy, and that was y equals x squared, but we need it in terms of y, so that is x equals root y. Okay, so the height is going to be 4 minus root y. That 4 minus root y is 4, and then subtract off root y. So you get that distance right there. Okay, so setting up the integral for shells, 2 pi r h. So we're going to do 2 pi times the integral of r times h. And we're integrating with respect to y. And now I need my bound, so I go back to this integral. And I'm looking for y's. It starts at 0, and it goes to right here, which is where x equals 4. And when, oh geez, look at what I just did again. This was y equals root x, which is where x is equal to Where's my eraser? Come here, buddy. The eraser, come here. Oh, that's not helping. Okay, well, it won't let me erase, so I'm going to scratch that off. So x equals y squared. And so this is the height is then 4 minus y squared. And so the height here is 4 minus y squared. Okay. Now let me worry about the bounds. Okay, so the bounds. Got dy. I go back to my picture. Y equals 0 to, when x is equal to 4, y is equal to 2. So from 0 to 2. Okay. So now, same region, but let's revolve it about. Same region, revolved about the y-axis. I'm going to draw the picture. We've got y equals root x. X equals 4. And this time we are going to rotate it about the y-axis. Okay, so if I draw a representative region in here, the height always goes through then I'm drawing a representative shell. The height goes through the region, so there's the height. And I'm going to take that and rotate it about y. Okay, so here I've got the radius, and then I also need to worry about the height. All right, but before I do that, let's think about what variable we're going to integrate with respect to. Now, if we're rotating about the y-axis here, we want to add up the first little shell it's going to be really little because it's down here on this thing, but it's going to be really little, and then they get bigger. We are going to add them up over the x-axis. So first shell, the second shell would be there, the third shell, there's its height, fourth shell, there's its height, fifth shell, there's its height, and notice all these heights I'm drawing are all along the x-axis. So we add it with respect to x. All right, now the radius. Remember I said that radius was always either x or y plus or minus a number. In this case, since it's starting at the positive y-axis and going towards x, that radius is going to be x. The height always has to do with the function, and in this case, because it's touching the x-axis, it is just going to be root x. All right, I think I have everything now. I can piece it together. So 2 pi times the integral of r, which is x, times h, which is root x. I'm integrating with respect to x, and now the bounds. X goes from, well, we were just told in the problem, 0 to 4. Okay, so now let's do one more, and I'll get this one right this time. So same region. And this time we want to revolve it about y equals -2. So same region, same region, same region. This was y equals root x. This is 4. And we want to revolve it about y equals -2. All right, so when I go to draw a shell in here, I'm going to draw the height through the region. So there's going to be my height. I'm going to take that little slice and revolve it all the way around y equals -2. So I'm going to revolve this all the way around y equals -2. And there's one of my shells. So there's one of my shells where there's the radius. And here's the height. All right, now what are we adding this up with respect to? Which variable? So if we look at the height here, if we got another one, maybe say a little bit higher here, we would have another shell. It would be a little bit skinnier but a little bit wider. And if we went down here, we'd get a shell that's a little bit fatter but a little bit longer. All right, so all of these heights are all being added up all along the y-axis. So that means that we are going to be integrating with respect to y. Okay, so now I need the radius in terms of y. Now from the positive x-axis up, that distance right there is a distance y. From the axis down to that line, that is always a distance of 2. So my radius is y plus 2. The height, we need the height in terms of the function. The height on this side, the bigger side, is 4, and then I subtract the smaller side. We want it in terms of y, and so that would be y squared. Right, because I have to take the function y equals root x, solve it for x, in which case we get the function is y squared in terms of the variable y. All right, so now I have everything to set up this integral. 2 pi times the integral of the radius, y plus 2, times the height, 4 minus y squared. We're integrating with respect to y. And y is going to go from, now I have to look at my picture again, and keep in mind with this, we only want to be adding this region. So it's a little intuitive to say you want to go from -2 to 2, and that's not quite right. We want y to go from 0 to 2, because those are the y values that bound that region that we're revolving. Okay, so I've seen formulas for these types of things that say if you're revolving about the y-axis or some line x equals something, here's what you would do with shells, or here's what you would do with disks. Or if you're revolving about the x-axis, here's what you would do. And to a certain extent, you can memorize a bunch of different formulas for this. I think it's easier to draw a picture and figure out from the picture your radius and figure out your height. I think it's easier than memorizing a bunch of different formulas, because all those formulas would be dependent on where your line of rotation is. Okay, I think that's it for this video.